In our field, I would like to introduce you as a bit of the company. We will focus on drone detection, but in fact, it's going to be the other way around. We're going to do customized LiDAR application for defense, from multinational situational awareness to drone detection. This is our specialty. We started being a LiDAR company like 10 years ago almost. And our specialty was building LiDAR systems which had very, very high resolution, very high spatial resolution. So we were able to concentrate a lot of points in a single image. This is not an accumulation of images, it's a shot, it's a frame as it gets out of the system. So out of that, we started working. We saw that everybody who bought a LiDAR from us placed a camera at the side. So then we evolved and managed to get a system which is more elaborated, which was the fact that we end up having an off-the-shelf system which is composed by 3 different imaging modes combined all together. So you got a solid-state LiDAR combined with an RGB camera and a thermal camera all together. So you can combine all the information that you get from the system in a single data flow, because all the system is fused all together, so you get only one single output cable where you are able to deliver all the flow of the data that you have there, and even you could embed inside of the system an artificial intelligence perception software inside the computer that the camera has inside for fusion. With this system, what we have seen is that it was beneficial, or the customers that we have been reaching are customers who have needs on computer vision, but in applications of computer vision where LiDAR is adding value, such as having situations where geometry, distances between objects, and so on are critical or are important. And with that, we have been very, very successful, integrated these kind of things in a single unit. This enabled us to work in applications with very little false alarms and working in all environmental conditions, because when one mode works, the other one may fail, but you still have one which is already working. This is a bit the idea of the system. We have been working in a number of applications in the past where essentially I would just show you 4 of the cases that we have been working with. We had, for instance, work done with DSTL and in collaboration with Thales on polarized LiDAR for object detection through the graded visual environments, where we were throwing smoke bombs in a test site in UK, testing LiDAR and polarimetric imaging through different degraded environmental conditions, showing that performance could be significantly enhanced. We also have been working with Mercedes in a test which they were building a LiDAR which they wanted to work in a multiplicity of polarization states, so they were able to combine whatever was looking at in the field in order to see through fog and smoke. Again, that's a specialty on site. So we got defense, we got automotive. We also have done things in space with Thales Alenia, where they were asking us to develop a space-qualified solid-state LiDAR. We started with the ground test, where we are. We're now running on an ESA project, also in collaboration with Thales. And where essentially here we learned that the main advantage that we have with our system is that as long as we were building LiDARs, we were able to customize them. So if you want a space LiDAR application, maybe you are not so concerned about frame rate, and you are more concerned about, I don't know, spatial resolution, for instance. So the ability to dial on them is one of the critical aspects that we have learned. And this has brought us to the fact that almost 75% of the sales of the company are based in customizing units for different types of customers. For instance, an example, we have it in railway, where we are also building, or we have built a sensor for a multi-sensory platform, including different types of cameras and different types of LiDARs, combining high-resolution LiDAR with multiple cameras for a well-known train manufacturer in Spain. Okay, but that's the multimodal thing that we have worked with, where we have multiple applications we could be showing. And now we are trying to push forward a novel product, which is essentially linked to drone detection, starting from LiDAR. We believe that LiDAR has many advantages for drone detection, because currently, now we will see a technology comparison afterwards, and LiDAR is going to be able to work in complex urban scenarios where some other technologies thrive, We are able to have 360 degrees for one single unit, and we are able either to have moderate low detection, low probability of detection, and very little probability of intercept, which is not the case. You cannot, in principle, jam a LiDAR if you shine the right wavelength in the right detector in the right moment. So it's complex to jam that. It's of course compatible with a mobile platform, and it's thought, or we have worked on it, starting from our experience in high resolution LiDAR to detect the small cross-section targets. We are to make it multi-target compatible, so we can have more than one at the same time with objects which are both static or in movement. And of course, that's something we can do with any laser. We're currently working at 1030, but that's what we have now, and we can work in any wavelength with the system that we are proposing, and we are able to get to ranges which are significant. So we expect to get 2 kilometer range, playing with the laser power once we are there. For the first unit, for the technology advantages of LiDAR for this kind of applications, I mentioned some of them. LiDAR is good with reliable, with complex scenarios, especially in urban environments. It's not having annoying echoes. Signal to noise ratio is very good, has low probability of intercept, has not a huge cost. Yeah, can cover 360 degrees, although we cannot go beyond 1-2 kilometers. And it's of course not so mature technique as others they are. So we have to start a little bit from the beginning. And of course, we have the issue of fog, which needs to be handled somehow. And the fog will be limited unless we go into longer wavelengths, which is something which is in the pipeline, but not for the current unit. For radar, of course, you see, I mean, it works, but it still has its changes. Can be longer range, can be better in fog, but has high probability of detection and intercept. It's susceptible to jamming, and in complex scenarios gives false detection. And of course, we all know about electro-optical vision units where it's passive, so it's very good regarding LPD and LPI, have very high spatial resolution and are mature, but you need several of them to get 360 degrees. You don't have range information, and they are also sensitive to fog unless you have it in the right wavelength, to say that way. The unit that we are building and are currently building, and later on we will show you the pipeline that we have for getting the product on. We are now having this performance foreseen for the field view, for points cloud spatial resolution. Angular resolution can be brought down to 0.067 degrees, which is very good for detecting things very far away. And with the current unit, we are getting numbers for 500 meters at 10% reflectivity of drones, which are small enough, like 35 drones. That's what corresponds to the angular resolution, 35 centimeter drones. That's what corresponds for the angular resolution. We're getting this kind of frame rate to Earth. Of course, the system which is 360 degrees turning around, and with accuracy that you are seeing here. The technique or the secret sauce is that we are working with MEMS. We got a novel patent especially conceived for this system, where we are combining or working with a novel approach to steering the MEMS beam, being able then to get these kind of resolutions. In the pipeline or the roadmap is to start, we started the concept in 2024, where we started the development of the system. Early 2025, we got the first patent. We are now producing and doing the first testing. By the end of the year, we had flight tests ready. And then we will get into a demo phase for customers, stakeholders, proofs of concept, testing it in different environments, to then, along 2026, industrialize and commercialize in 2027. This is the map of the developments that we currently have for this anti-drone system. The full system is going to be composed of course, of more than one unit. We will be able to do LiDAR for tracking. We will be able to do LiDAR for detection, but we will not be able, in particular at long distance, to do recognition and identification. So for that, we will combine them with a 2D imager, which is able to detect with a good zoom, is able to detect the right scene. So we are able to afterward process and recognize and identify which is the threat. So the idea would be that there will be a two-side system. And of course, with that, we will have some AI-based system, which is going to enable us to detect whatever we have and process whatever we need for the recognition identification and for the tracking. And that's it. So following the advice of Epic, which I'm very happy to follow, what we can offer to all of you now is, in particular, if you are a camera developer and you have particular features which you believe can be integrated inside our units into our something which is multimodal, which adds on LiDAR, where geometry may be critical in the application you target. That's something we can help. And of course, we can support developments in perception system, customizing them with the hardware, with the software, etc. Just to stress a bit some key features that we have, of course, fail-proof systems by multimodal imaging, but our main expertise is MEMS mirror control. So if you are working with MEMS, we are also able to help you in many fields. And of course, we have worked for years in challenging environments. So if you want help, let's talk. We are also in the field of some applications in free space optics, adaptive optics, medium wave infrared. We're working in several applications in this field at the same time. And how can you help us? Well, we are looking for demos and proofs of concept required for the drone detection unit. And if you want advanced perceptions and you are an end user or an integrator, just let us know, because we have experience working in several markets, as you see, and we are developing finished solutions in many fields. So that would be mostly what I would like to point out. I hope you find it interesting. And in any case, thank you very much for your kind attention and for Epic for the invitation.